atoms are mostly space.
Not
But
in terms of the hollow Earth.
yeah, well, I wouldn't say that the hollow Earth it has that much space. If there's a black hole at the center of the Earth, which I believe there is, it's fairly small because it wouldn't take a very large black hole to generate the energy that we observe on Earth. Go ahead.
Could you describe the order of magnitude size of the event horizon of that black hole?
Of the black hole of the Earth?
Yeah, the range perhaps, the limits?
Yeah, it would be in diameter. It would be very short. It would be, you know, the size of a ball that big. You know, it wouldn't be that big. Yeah.
On the order of half a meter less down to something like 0.
Yeah, exactly. Now it's not all done, that part, because we haven't made these calculations. We've made them for the sun and we've made them for other things, but we haven't made it for the Earth yet. But the theory would predict that there is a black hole at the center of the Earth, and that we're orbiting that black hole, but we're orbiting that black hole so far from it that we're in a place where there's weak gravitation, and we're far enough from the surface of the event horizon that the plasma had time to cool off, you see, that far from the event horizon, and it became more solid, you know, and that's why we have a crust around the black hole.
Is that plasma that you're relating to similar to what I read of Hawking radiation?
Yes.
Yeah.
Hawking radiation is the radiation on the surface of a black hole, but the Hawking radiation is really weak. The thing is that they're not calculating the plasma dynamics that are going along with the Hawking radiation, meaning all the plasma, you know, being so close to a large gravitational field and all the thermodynamics effects and all the charge effects creates all this radioactivity, all this electromagnetic activity, and all the radiation we see coming out of black holes. Go ahead in the back.
The previous computer frame looked at a glimpse. To me, my first impression was, or one of the impressions I had was, of magnetic flux lines around the Earth. And I'm sure that's no accident.
That's right. You're talking about the Coriolis effect. The Coriolis effect is very similar to this, and we'll see that in a minute. So you're right.
And that's the same that plays out in both magnetic and electronic flux lines.
Yes.
Wherever, however the magnitude, wherever.
Yeah, at any scale, you find the same dynamics of the double torus and the structure of the vector equilibrium at singularity at all levels of the scale. So you'd expect the same dynamics to appear, and that's what we see. From electron cloud, probability clouds, to the clouds of a supernova, you know, up in the sky. So, you know, that's a span of a very large scale.
In that one, it almost looked one-dimensional, like it was a flat picture.
Yeah, but it's not.
In fact, it's completely full?
Yeah, yeah.
Okay.
And so after I saw all this and I was like all excited about the dynamics that we were being able to picture, it was nice to see this guy show up and in this conference and tell us exactly what it is about.
So the remnant that
Yeah.
is the result of a star that exploded in our own galaxy in the year 1054 AD. And as we watch these things explode and get bigger and bigger, they're beautiful to look at. By the way, the one at Nassim Haramein in 1987 has evolved into a very interesting looking expanding remnant. If you look just at where the exploding star used to be now with Hubble Space Telescope, you see this rather strange looking structure. If you zoom in with Hubble Space Telescope and look at the remains of the 1987 supernova, here's what you see. And I'd like you to sigh again, please. That was better. Thank you. Okay, now what is this? I mean, it looks like sort of nested hula hoops. I mean, how did it possibly get that way? And there's a solid astrophysical answer for that. It's just 2 words, and it's nobody knows. There is predicted a structure like this if it hadn't been observed by Hubble Space Telescope. So these remnants are very exotic things, but what they share in common.
Well, you know, he didn't know about my work, obviously, because I did predict it. And so, is this the right thing? I think so. So I thought that was interesting, you know. It was like, oh yeah, well, you know, I did talk about that, but one of the problems here is that the images are showing, like you were saying, a 2D type of structure, when actually we're talking about a spherical structure. Let me see. And the dynamic of that spherical structure are the dynamic of a double torus that looks like this. See, if I took this double torus and I took a picture of it at the right angle, it would look like two spheres intersecting as well. These are the dynamics of the standing waves of the surface of the black hole, of the double torus, predicted by this theory. And here you can see the expansion and contracting side of the universe dynamics. And this is the path of a test particle on the surface of such a black hole. This is the dynamics of the Coriolis effect. On the Earth, you find the same Coriolis effect. For instance, the weather has, you know, the patterns of the weather goes down to the equator, gets hotter, and then goes back up to the North Pole and back down towards the equator, and so on. And the one from the South Pole goes from the South Pole to the equator and back down, creating this exact dynamic. And I thought it was interesting, although I didn't mention it at the APS, that the view of these dynamics from above is a yin and a yang. Yang. And yin yang. I'm sorry. And you know, and we'll see in a minute why that's so crucial. But these dynamics are found at all levels. This is the paper I'm publishing now. And you can see that these dynamics are found at all levels of stars and galaxies and blazars. This is a galaxy. Galactic disks have 3,000 light years vortices that emerge from the black hole at the middle. Okay? And they have huge galactic halos all around it. Can everybody see this? All around it here. And the stars move out from the galactic arm into the galactic halo and then back down and then back out. Go ahead.
What are you saying, the obvious, to say that the double taurine Coriolis effect, that we can imagine that our bodies have that same type of energy pattern around us?
Yeah, you would, and that's why I think that the Buddhist shows a vortex entering at the crown chakra and entering at the root of the spine, and then meeting in the heart center, reproducing that very dynamic. And when you look at the heart center of the Buddha, where the vortex meet, there you find the geometry of the Star of David, or the geometry of the double star tetrahedron, the geometry of the vacuum, the singularity. So it's present in many, many different traditions. And actually, I did develop a meditation technique based on this to improve and to increase your capacity to move the information through from the vacuum into your singularity. There is a physical place inside your heart that has a singularity. Your heart has a little cavity between the two ventricular of the heart. And that little cavity has the highest electromagnetic field of your body. It can be measured up to 8 feet away from you. And that's the battery of life that keeps your heart going. When you die, that singularity is no longer present, and I think that's one of the reasons that they're missing a bunch of weight that they can't account for that disappear when people die. The weight is the result of that singularity curving space-time, creating a gravitational effect that we call weight. Go ahead.
You said you developed a meditation technique around that. Do you have that on a tape or a CD that you're selling?
No, not yet.
Could you do